Hi there, the following video will answer question 2 part II of the OCR Core 3 Maths January 2010 past paper. Okay, let's start off by reading the question. Given instead that theta satisfies the equation 8 cos theta cosec squared theta equals 3, find the exact value of cos theta. Quite a lot of information is given here in this question. Given instead that theta satisfies this, that means that you have to ignore what you found out for sine theta and cos theta above. If it meant for you to use the above, it would say that given as well theta satisfies this. This is a new fact about theta, and you are to ignore part I fact. Also, what are we trying to find? Well, no one's asked us to find theta. We're asked to find cos theta, and we also need to find the exact value. So I don't want to see rounding to 3 significant figures like you usually would. This answer will probably have a surd or fraction in it. Let's go ahead and write out what we know. We know that 8 cos theta cosec squared theta is equal to 3. We do also know that theta is an acute angle. It's between 90 and 0. Okay, looking at that, you might think to yourself what to do. There's a few ways to do it, but what I would do is remind yourself what cosec theta means. Let's remember, cosec theta actually means 1 over sine theta. That's how we define it. So therefore, this function squared, we write that as cosec squared theta, is just 1 over sine theta all squared, which we write as 1 over sine squared theta. Okay, we could substitute in for cosec squared theta into this equation we have. That may help us. Let's have a go. 8 cos theta multiplied by 1 over sine squared theta is equal to 3. Let's just take a pause and remind ourselves what we're trying to do. We're going to try and find cos theta. We've got a cos theta here. We haven't got cos theta here. We've got a sine squared theta on the bottom, on the denominator of a fraction. Why don't we multiply both sides by sine squared theta to get the sine squared theta off the denominator of this side? If we did that, we would have 8 cos theta is equal to 3 sine squared theta. Now, we want to find out cos theta. Currently, we have a sine squared theta here. Do remember this most important identity. Cos squared theta plus sine squared theta is equal to 1. And that rearranged tells us that sine squared theta must be 1 minus cos squared theta. This is an identity that gets used again and again and again. Why don't we substitute for sine squared theta in here? Everything then would have a cos in it, a cos theta. So we have 8 cos theta equals 3, 1 minus cos squared theta. Open up these brackets, expand. We get 3 minus 3 cos squared theta, and all of that is equal to 8 cos theta. Now what? Well, if we add 3 cos squared theta to both sides and subtract 3 from both sides, or sometimes you think of it as taking the 3 and the minus 3 cos squared theta over, so one side of the equation is 0, we would get 3 cos squared theta plus 8 cos theta minus 3 is equal to 0. Well, that's a quadratic in disguise. You can factorize that as follows. 3 cos theta, two numbers that multiply to minus 3 and add to, and then you need them to eventually add to a. It would be a plus 3 and a minus 1 would work. So therefore, on the one hand, cos theta is minus 3, but you can ignore that because cos theta is always between 1 and minus 1. But on the other hand, 3 cos theta minus 1 equals 0, so cos theta is equal to 1 over 3. Now we have found an exact value for cos theta, which is a third. It makes sense because theta is an acute angle. Thank you very much.